Welcome to the mini course Python Data Types for Data Handling. This mini course will teach you some concepts and teach you to use some Python data types with the perspective of data handling. You will learn deep and useful knowledge about Python data types, for example, Python integers, floats, strings, and string methods, all with the perspective of data handling. My name is Henrik Johansson and I will be your teacher for this mini course. I have 20 years of instructing experience and have taught students from most backgrounds, from high school students to doctors. In this mini course, I will teach you some concepts and you will learn how to use some Python data types. All right, let's talk about Python data types. And Python data types is an abstract concept framework which is used to classify Python object types. The most common Python data types within data handling are integers, floats, and strings. Various definitions of Python data types may include Python data storage abstractions. They may also include logic, abstract sequences, and even objects made to convert one object type to another object type, or even uncommon non-Python data objects. In this mini course, we will teach you to use Python integers, Python floats, Python strings, and Python string methods. You will learn deep and useful knowledge about Python integers, floats, and strings, all with the perspective of data handling. We will skip the complex data type because it has very little practical explicit use in data handling applications. It requires a bit more mathematics and abstract thinking, plus that its use generally is limited to certain uncommon special applications. And while we consider Python data storage abstractions such as sets, tuples, dictionaries, and lists to be Python data types, we have placed them in a separate mini course because they require special treatment within data handling. This video is the introduction video to this mini course, and we want to say that this mini course is designed for everyone who wants to learn to use data types such as Python integers, Python floats, and Python strings. We aim at going a bit deeper than most other video courses, and this mini course is therefore suitable for both beginner Python users and people who want to learn tools that will enhance their coding, data science, data analysis, data handling, or machine learning capabilities. We look forward to have you continue to watch this mini course. Hello and welcome to this video about Python integers for data handling. We are excited to have you here, and in this video you will learn to use Python integers, which are a fundamental tool to be able to use Python for data handling, and also a fundamental tool for any type of computations with computers. Python integers are a necessary tool for all types of basic counting and data handling. We can use Python integers to represent counts of items, represent the number of iterations of a function, memorize any type of number, represent the location of an object in a list or an array, or, for example, an integer can be used as a representation of change in a function. Let's talk some more about Python integers. Integers are a fundamental data type in Python, and a Python integer is defined as a native Python object. When we say that the Python integer is a native Python object, we implicitly compare it against the machine code integer, which conceptually most often is an address to a position in your random access memory that holds a value. most often nowadays of the 64-bit data type. The Python integer is different from this in that it provides object methods and encapsulation, a piece of code protecting the integer number data value from being accidentally overwritten. Python integers are therefore useful and accessible from a data handling viewpoint. And as we in this video aims at data handling rather than object orientation, we will not study the details of object orientation with Python integers, but study how Python integers are useful for data handling purposes. Noteworthy properties of Python integers are that when we talk about Python integers, we usually abbreviate them as single ints or many ints. If everyone knows that we use Python, we may drop the word Python. A Python integer can only consist of whole numbers without decimals. And this is important. Integers in Python 3 have unlimited size, which makes Python integers very easy to use and very convenient to use for data handling purposes, as there is only one type of integer, not 2, 4, or 8 types of integers. And this means that a Python integer can be any type of number, such as 34 minus 91. It can be 1, it can be millions and billions, but what it cannot be is an integer with a fraction. Different Python data science and machine learning libraries may use other types of integers than Python integers. And this is mainly due to speed, as a Python integer is much slower than an integer which directly can be fed into a machine 64-bit coded library. And it is therefore important to know your integers and libraries. And this is in particular important when you use libraries which has functions which create returns, because these libraries often accept Python native objects as input, but may return for example, a NumPy 64-bit integer instead of a Python integer. And this can convert your Python integer into a NumPy integer, which is fast but not perfectly convenient for all types of data handling. So, is speed important for data handling, and how do Python integers' slowness affect data handling? This is the case. Most persons doing data handling spends 97% of the time planning and coding, and 3% of the time waiting for computations. Python integers speed up the 97% greatly, and other integers may speed up the 3% greatly. Take your pick. I give you this idea. When you develop stuff, Python integers and dynamic typing is fast. When you have a piece of code that is reused time after time can be spent on making it faster. So right, now we'll talk some about how Python integers are created. So, how is a Python integer created? Python creates an integer by assigning an integer value to a variable. For example, the variable whole num in this example on your screen. And in this example, we assign the variable whole num the value of 5, and we will put a comment next to it. So in this example that you can see on your screen, we take the variable whole num, we assign it the integer value of 5 with the equality sign. So we have whole num equals 5. And then we write the comment sign, which is the hash mark, and to the right of the hash mark we type integer value to remind us that 5 is an integer value, and that the variable is an integer because we assign it an integer value. And we can use the print command and print the value of the variable by printing the variable between the parentheses of the print command. And when we run this code, it will assign the variable whole num, the variable 5, and it will print 5 to the screen. And in this case, we use the print command to show that the variable exists and that it has a value. And another way to check the object type is to use the type function, for example, to print type of, for example, whole num or an int. All right, now it is time to type some integer code. So let's start our code editors and we will show you this code and how to run this code in practice. All right, having started our code editors, we will type some Python integer code. And a great exercise for these master Python for data handling videos is to replicate the code which we are typing. And this code which we are typing will be downloadable from the course resource page. But as an exercise and to learn to type Python code and to integrate it in your memory, it is important that you actually type this code in practice. And typing this code in practice means that you will learn the most from this video. Otherwise, it is easy that these videos just become like a book which you will open every time you write this code. So, right, now we'll start to type some code and we will start typing a comment sign which describes our code. So we will type Python integers like this. And we will create our first integer. And we could say Python integer. And we type whole num equals 5. And this Python integer is created through assignment. And this means that this Python integer is created by the sign of equality and the number 5 when we run this code. And to show this, we will print whole num. And this print instruction will print the value of the integer whole num when we run this code. And in this case, the value is 5. So let's run this code. And to run this code in this code editor, we use the run button here, or you could use the run menu here. So let's run this code. And here you can see that it typed 5 to our screens. And now we'll create more integers and add them together using assignment. So we type create more integers and add them together to create new integers through assignment. So we type num2 equals 3. And this is an integer value. And we type num3 equals num2 plus whole num. And here we will say that an integer value plus an integer value is an integer value. So we print num3. And in this case, it will become 8 because num2 is 3 and whole num is 5. And 3 plus 5 is 8. So let's run this code. And it printed 8 to our screens. And now we'll test subtraction, multiplication, and division. So we type test subtraction, multiplication, and division. And we begin with subtraction. So we create num4 equals whole num minus num2. And here we state that an integer value minus an integer value is an integer value. And we print num4. And in this case, it will be 2 because 5 minus 3 is 2. So let's run this code. And it printed 2 to our screens. Now we'll test multiplication. So we create num5 equals num4 multiplied by num3. And here we state an integer value multiplied with an integer value is an integer value. So we print num5, and in this case it will be 16. So let's run this code. And it printed 16 to our screens. And now we'll talk about division. And division is different. So let's test division. So we type num6 equals num5 divided by whole num. And here we will state that two integers or two integer values divided with each other returns a float if a single division sign or slash is used. So we print num6 and this will return 16 divided by 5 or 3.2. So let's run this code. And here we can see that we had 3.2 printed to our screens. And 3.2 is not an integer, but another data type, which we will talk about in the following video lectures, which is called a float. So now we'll perform some type checking. So we type checking, and we print the type of num5, and we print the type of num6. And in the first case of these two lines, it will print that the object is an integer, and in the second case, it will print that the object is a float. So let's run this code. And here you can see that num5 is an integer and num6 is a float. So all right, the reason that integer division is different is because it is executed by different circuitry in the computer or central processing unit or graphical processing unit. We do, however, have the option of floor division. So let's test floor division. So we type floor division. And here we create num7 equals num5 floor divided by whole num. And here we state that two integer values floor divided with each other returns or creates a rounded integer. So we type print num7 and we type check it. So let's run this code. And here we can see that we returned 3.2, floor divided became 3. It is rounded, and it is an integer. So all right, let's take a look at the use of integers as a part of native Python functions. So we type integers can be used to keep track of loops, or you could say Python loops. So we type for x in range of 1 and 6, print x. And this code will use an integer x, and for every iteration or execution of the loop, increase x with +1 from the integer 1 until x is less than the given integer 6, which is 5. So let's run this code. And here we can see 1, 2, 3, 4, 5. And this is one of the reasons that integers are important. They are used to keep track on all things, for example, loops, positions in arrays, numbers, and all such things. As a matter of fact, even when you see these characters on your screens, behind every one of these characters is an integer number that corresponds to, for example, the letter T or the letter W or all the other letters. So everywhere on your screen there is integers. And you simply can't escape having knowledge about integers when you type code. So all right, now we'll take a look at converting other Python data types to ints. So let's type other data types can be converted or cast as integers if the data type's value is suitable. So we type num8 equals integer 5.5. And this code will cast a float 5.5 as an integer with the value 5. And we can type number 9 equals integer, and in this case we give it a string 3, and this will cast the string 3 as an integer with the value 3. And we will print num8, and we will print the data type of num8. We will print 9, and we will print the type of 9. num9. And let's run this code. And here we can see that we successfully converted our casted floats and strings to ints. So now we have learned how to cast or transform, for example, returns from other libraries to Python ints or other simple Python data types to the Python integer data type. All right, this has been a fast first practical hands-on video lecture about Python integers for data handling. In the next video, we will teach you even more. And if you continue and use the same notebook, please remember to delete the currently used cells or simply start a new notebook. We look forward to see you in the next video. Hello and welcome to this video about Python floats for data handling. We are excited to have you here, and in this video you will learn to use Python floats, which are a fundamental tool for any type of computations with computers and a common data type for data values when performing data handling. For example, Python floats are a necessary tool and data type for most types of fundamental data science and machine learning algorithms, methods, or technology, math, statistics, and data handling. We can use Python floats to represent numeric numbers, outcomes of numeric calculus, parameters of models, coordinates, continuous feature variables, and we can approximate fractions. Moving floats around is a common task in data handling, either moving floats between data storage containers or using them in algorithms, methods, and calculations. Let's talk some more about Python floats. Floats are a fundamental data type in Python, and a Python float is defined as a native Python object and abbreviated as a float. Digitally speaking, a float is an abbreviation for the concept of a floating point or a reference to the Python floats constructor function that creates Python floats. A floating point is a way of simulating some fractional numbers or a way to define numeric coordinates. Currently in Python 3, floats are defined by using 1 bit for designating if the float is positive or negative, 52 bits for the mantissa, and 11 bits for the exponent, for a total of 64 bits or one standard 64-bit RAM memory location. This is not a course in floating point math, so we will simply state that this memory allocation, together with a piece of code defining this as a float, combined with a floating point unit or piece of code that can simulate a floating point unit or perform the same task, is sufficient to use Python floating points. In Python 3, a Python float is a native Python object, and the current Python float is implemented using a double definition in the C language. So what are the consequences of a Python float being a C double? The practical implications and consequences of the double C is that the standard Python float has a large but defined range as compared to the Python integer, which has unlimited size. It also means that the Python float is unexpectedly fast because it is often executed with C libraries, and C is a very fast language, but which is very complex to use. And this also means that the Python float's range is huge, but limited between two incredibly large numbers. And if a number is outside of this range, the float constructor may throw or generate errors if used on numbers larger than the numbers within this range. Three other implications are that certain fractional numbers cannot be defined as floating point numbers, but are rounded to the closest creatable floating point number, and that a Python float can store values up to 15 decimals without any loss of precision. And this mentioned loss of precision can in some calculations create mathematical divergences because the product of the calculus is either unintentionally rounded to the closest double precision number, or because a large number of calculations are serially rounded in the same direction, with an increased error in the same direction as a result. But what we can say is that Python floats are highly useful for most data science and machine learning tasks without modification or augmentation. Now we'll talk some about how Python floats are created. So alright, how is a Python float created? And Python creates a float by assigning a decimal value to a variable. For example, the variable real num in this example on your screen. In this example, the variable real num is assigned the value of 5.3, and we have made a comment next to the number using a comment sign or hash mark to remind us that we create a float with a decimal number which has a float value. And we can use the print instruction to type the float to our screen, or to, for example, type check the float using the print type real num instruction. So alright, now we'll type some more code examples. So start up your code editors because we are going to type some code. Alright, having started our code editors, we will type some Python float code. And we will begin by naming this video Python floats. So we type Python float, and we will create a Python float using or with assignment. So we type real num equals 5.3, and we use the comment sign, the hash mark, and we type real num equals 5.3. A Python float is created through assignment. And we will print real num, and this will become 5.3. So let's run this code. And it type 5.3. And now we will create more floats and combine them together to create new floats through assignment. So we type floating point 2 equals 3.2. And this is a float value. And we will print floating point 2. And this will print 3.2. So let's run this code. And it printed 3.2. And we will try addition. So we type floating point 3 equals floating point 2 plus real num. And we will state that a float value plus a float value is a float value. So we type print floating point 3. And this will become 8.5. So let's run this code. And the machine printed 8.5. And now we will try subtraction. So we type floating point 4 equals real num minus floating point 2. And we will state that a float value minus a float value is a float value. So we type print floating point 4 and this will be 5.3 minus 3.2 equals 2.1. Or will it? Let's run this code and test. And here we can see that 5.3 minus 3.2 in the floating point world is not 2.1, but 2.099999996. So let's round the result. So we type print round floating point 4 dot 1. And we run this code. And here we can see that we successfully rounded the floating point number to its mathematically correct number. And this issue is caused by the 64-bit floating point's inability to store certain numbers exactly. And in the ancient days, when we were using 8, 16, and 32-bit floats, this was a great cause for many bugs and problems, also in ordinary everyday calculations and computer applications. With the 64-bit floating points, this is a non-issue for 99.99% of all cases. So right, now we'll try multiplication. And here we will show this little divergence. We will create a floating point for B, and it will be equal to floating point 4 rounded to 2.1. So here we will create floating point 5, and it will be floating point 4 times floating point 2. And we will state that a float value multiplied with A float value is a float value. And we will create a floating point 5b, and it will be floating point 4b times floating point 2. And we will print floating point 5, and we will print floating point 5b. So let's run this code. And here we have an intriguing fact. If we cheat and check the mathematically correct number, it is 6.72 without any more decimals. But here we have obtained two answers, which both are approximations of the correct answer. So we can ask ourselves which one is correct. And we can say that both numbers become the same number when properly rounded according to the rules of mathematics and measurements. And we can say that round is a bit more correct according to these external rules of the mathematical language and the rules of thumb of measurement, which is a different rule set usually used with programming languages, electronics, mathematics, and the measurement of the measurement system itself. So we can say that round floating point 5 is the rules of math and measurements way. But in reality, when you work with code, and in particular code which someone has written, you will find that this will be the most common. So round floating point 5b most often happens in practice. And we can say that combined with floating points, or you could say either floating points in the software or floating points in the hardware, is a contributing cause to space rockets and aircraft crashes. Missiles missing targets, and measurement errors in general. However, for 64-bit floating points or bigger sizes of floating points, these rounding errors are most often negligible. We could say for any ordinary applications. And this statement is not necessarily true for 8, 16, or 32-bit. Floating points. However, as Python uses 64-bit floating points as the least sizable floating point, this issue will only affect Python applications in certain highly unusual ways, which we will show a bit later in this video. So first, we will try division. So we type floating point 6 equals floating point 3 divided by floating point 2. And we will state that a float value divided with a float value is a float value. And we will print floating point 6. So let's run this code. So right, now we'll take a look at these special floating point calculations. So we'll state that floats are used in many calculations, and we will create a trivial badass example of a floating point equation which goes bad. Or you could say to a very bad place. We start by creating some variables. So we will create the variable result, and we will, in this example, initialize it to 1 because we will use multiplication. So we type floats are in this example initialized at 1.0 for use with multiplication. And we will have a result b, which we also will initialize to 1. So we will type for x in range of 1 to 6, result equals result times x times floating point 4. We will have a result b, which is equal to result b times x times floating point 4. We will print x times floating point 4. We will print x times floating point 4b. We will print result A. We will print result B. And we will print result minus result B. So let's run this code and we will take a look at the result. And here we can see that it iterated and the most interesting part of this equation is this final command where we print the difference between these two equations. So here we can see minus 4.4, 16, 15, 14, 13, 12. So what we can see here is that this is a very small number, but this is a bigger number, and this is an even bigger number. And here it grows and grows and grows. And this number that grows is the difference between what we believe is the correct number when we are talking about the rules of math and measurement. And the other number is the number which you are very likely to encounter in practice. Because when people create calculations, they usually use modularization. And every guy that handles a module will use the round function on his return to the calculation. And likely he actually uses exactly the same rules of math and measurement. It is just that they are being applied in a subtly erroneous way, because the guy who makes this module, he has no clue that a large number of other guys will make other modules, and that all of this will be combined into one big algorithm, and that this algorithm will be run millions and billions and trillions of times, or add millions and billions and trillions of data values together, and that these errors may accumulate as a function of the floating point unit's physical properties in the computer, or as a result of the software that uses this floating point unit, or as a function of the code which the programmer has written. So all right, we will play a little bit with this example. So we will increase the size of the floats through the loop to visualize the differences due to the round function and this setup, because this is an artificial example which I have designed to display this issue. So we will take this code and we will cut and paste it. And we will add another number like this. So let's run this code. And here we can see that the difference is growing. And you can see something interesting here, that it has crossed the 0. And it is growing and growing and growing. And here it has reached a size which is hideous. And as you can see, if this was a measurement application, then you would have a quite sizable error. And this is the type of error that causes aircrafts to crash. And if you have your computer on for several days, for example, you will notice that it feels like your memory has somehow been filled to the brim and your computer is very slow. And this particular bug is a very common cause for these slowness or crashes over time. So what we will do now is that we will increase the size of the floats even more through the loop to show what can happen over time. So we will cut and paste the same code again, and we will add 2 numbers. And running this code will not cause any problems on your computer, because Python is designed to handle this issue. But if you don't have a proper catch effect for this type of error, then a computer could, in practice, crash. So let's run this code. And this is intriguing, because here we have numbers that are so big that they are outside of the range of this 64-bit float. And it has triggered an overflow error, which has been catched by Python, and Python has been coded to replace this overflow error and the floating point with an abbreviation inf for infinity. So Python believes in this case, because it is not coded for handling big numbers, that the number is so big that it could be considered to have reached infinity. And an infinity minus an infinity is not a number. So right, we have some conclusions. If the floating point unit or code cannot properly define a number, rounding that improperly defined number will not change this fact when using that rounded approximated number in calculations, as rounded to 2.1 will be returned to even when using round and we can say that this happens the next time 2.1 is sent to the floating point definition and circuitry. And we'll state that this is a property of the floating point definition and circuitry. So here you have first a design of the hardware, and you have a design of the software. And these are very overlapping with each other. So there are some things which you can code and some things which you can't code because the circuitry is made a particular way. So you have to cope with this by specialized circuitry. Use a 128, 256, or 512-bit floating point. Or you can simulate a floating point in RAM memory. And we should say that the grave danger is when something in the calculation creates a permanent difference between rounded floating points and floating points. And we should say that this is what we created in this artificial example. Or you could say badass example, because here we have violated lots of rules. So, all right, let's take a brief look at casting or converting other Python data types to Python floats. So we type floating point 7 equals float 5. And this code will cast the int 5 to a float 5.0. And we will create a floating point 8 as float free.free. And this will cast the string free.free to a float free.free. So we will print floating point 7, and we will print the type of floating point 7. We will print floating point 8, and we will print the type of floating point 8. So let's run this code. And here we can see that the int was cast to a float and that the string was cast to a float. So let's try to convert a suitable Python float to a Python tuple with two Python ints. And these Python ints will describe a fractional number. So we will use a Python float and try to convert it to a fractional number where we have two ints representing the fraction. And a Python tuple is a type of Python storage container, which we will study later in this video course. So, all right, let's type floating point 9 equals 0.5. And we will type that 0.5 mathematically is equal to the fractional number 1 divided with 2. And we will create a ratio tuple, which will be floating point 9 as integer ratio. and we will print ratio tuple, and we will print string ratio tuple 0 plus the division sign plus string ratio tuple So let's run this code. And here we can see that we have floating point 9 first as the tuple, the ratio tuple. So here we have the storage container with two integers. And here we print this storage container with some graphical edits. So we cast the first integer in the ratio tuple as a string and also the second, and we add them on each side of this slash or division sign. So here we can see that we successfully converted or casted floats and strings to ints and ints to strings. So right, this has been a fast and detailed first practical hands-on video lecture about Python floats for data handling. And we are confident that you have learned almost everything which is useful when it comes to Python floats and data handling. And as we said, this is not a course in floating point math. So here we have just shown you how to detect or understand this issue with the floating points. So if you ever sees this, you could say, divergence in the calculations, you know what it could be. So you will have a very easy time to detect this issue and find a way to handle this issue, whereas a lot of other persons will try to find the error in other ways. And technically speaking, the human brain and mind is designed and educated in such a way that people will look for calculation errors. So when you have these rounding errors, they will see 2.1 and they will say 2.1 is mathematically correct and therefore it is not an error. So people who are not aware of this, they can look for this error forever and they will never find it. So you can take professors in engineering, even professors in math, and you can have them look for this bug all day long and they will never find it. But you might find it. So, all right. In the next video, we will teach you even more. And if you use the same notebook for the next video, please remember to delete the currently used cells or simply keep your current notebook and start a new notebook for the next video. And we look forward to see you in the next video. Hello and welcome to this video about Python strings for data handling. We are excited to have you here, and in this video you will learn to use strings, which are a fundamental tool to be able to use Python for most types of text-based data handling and texts or descriptions in general. Python strings are commonly used in almost all types of machine learning, data science, model building, data handling, graphics, and report writing. And being good at handling the Python string data type is a sure way of being effective at almost any type of data handling. If you can handle the strings, you are able to handle the rest, and Python strings has many distinct simplicity and functionality advantages over strings in other programming languages. Python strings are therefore very useful and very easy to use. Strings are a fundamental data type in Python, and strings is the main non-numeric data type in terms of what a string represents, which commonly is characters, letters, words, numbers, sentences, paragraphs, books, date times, geography, descriptions, paths, or locations in computers or data storage, or structured data can also be defined using string structures. In Python, a string is an array of characters between quotation marks, and a one-character array is also defined as a string in Python. This is very different from other programming languages, which have many types of strings and also defines single characters or letters as a separate data type or construct. As a consequence of Python's definitions of strings, Python strings are immutable sequences, and this means that in practice, every time a string is changed, a completely new string object is created for the new string. So, if you have a string, let's say, "this course is great," and changes the string to "this course is the best in the world," then an entirely new string object, "this course is the best in the world," is created, and the old string is removed from RAM. And this is an important feature of Python strings to keep in mind when you work with strings, because strings are one of the most commonly used, stored, and created data objects, and also one of the most studied data objects within data science and machine learning. Technically, under the hood, Python creates strings as a set or array of integer numbers representing characters. Exactly how Python strings operations technically is implemented under the hood is a non-guaranteed property of Python. The string operations are guaranteed, but not exactly how they are executed under the hood, or which lower-level programming language is used by Python to create Python strings. When you work with strings in Python, Python will create a string by assigning a set of characters between quotation marks to a variable. Depending on how you work with strings, strings can be efficient or they can be inefficient. Another thing to keep in mind when handling strings is that many Python libraries use their own string definitions. For example, within data handling, you will often encounter NumPy strings and PyArrow or Apache Arrow strings. So let's take a look at how Python creates strings through assignment. And now we'll show you this in a simple fashion with an example on your screen where a string is created. We will simply call the string example string, and the string will be created through assignment by using the sign of equality and the set of characters "hello world" between two quotation marks. When this line of code is run, the string is created. And this string and all Python strings are considered to be an iterable array. And this means that we can address the string's individual characters as if the string was a Python list or tuple. And we will demonstrate this Python string feature later in this video. And before we start to type code, we will also say that the object type of a string can be checked with the print type string object function. So now we'll type some Python string code, so start up your code editors because we will type some code. All right, having started our code editors, we will type some Python string code, and we will demonstrate a few additional properties of strings. So let's begin with the string hello world example. And we begin to type Python strings. And let's start with creating the example string and print it to screen. So we type example string equals hello world. And we type a string is created using assignment. And we print the example string to screen. So let's run this code using this run button. And the machine typed hello world. And now we will print the object type or class of the string object. So we type print type of example string. And we run this code. And as you can see, it typed class string. Now we'll add two strings together. So we type let's add two strings together to create a new string through assignment. So we type example string 2 equals again. And we type example string 3 equals example string plus example string 2. And we print example string 3. So let's run this code. And as you can see, the machine typed hello world again. And let us edit the output better because string output commonly need a lot of editing. So we type example string 3 equals example string plus white space plus example string 2. And we print example string 3. So let's run this code. And here we can see that the machine typed hello world again. And this looks a bit better than this. And if we want to, we could add a comma. For example, we could rerun this code like this, or perhaps more suitable like this. And as you can see, it is very easy to edit strings in Python. So let's take a look at the iterable property of Python strings. We will take a look at the part of a string using a loop. So let's type for x in range of the length of example string 3, print example string 3 like this. So let's run this code. And here we can see that we have printed the letter or character X on each new line. And as you can see here, in the first iteration of this loop, X is 1, and the first letter of the string or character of the string is printed. And on the next iteration of the loop, X is 2, and it prints an E. So let's show some string tricks, and let's turn the output to one line. We create an example string 3a, and we make it empty. So we create an empty string, and we type for x in a range of the length of example string 3. Example string 3a equals example string 3a plus empty space plus example string 3 and in this case we will print the string which we have created, example string 3, after the loop has finished with its iterations. So we print example string 3a. So let's run this code. And here we can see that we printed our string with added white space, but on one line of the screen. And we can see what happens if we remove this white space. And run the code. And here you can see that it typed hello world again. And as you can see, it is very straightforward to work with Python strings. Let's study this string a bit deeper. We create an example string 4, and we make it an empty string. We create an empty string object, and we type for x in range of the length of example string 3. We will create an example string 4, which is equal to example string 4 plus example string 3. And we will print example string 4 plus some white space. And we will run this code. And here we can see that we started with an empty string, and we had our loop, and on the first iteration x became 1, and it took the first letter from example string 3 and made it example string 4, and we added a white space and the length of this string. So here we have counted the length of this string 4, which we have created. And the most interesting thing to see here is that white spaces counts for the computer. So you can't see the white space, but it's there, it has a number, and it counts. So this is important to understand. White space string spaces are string objects. And we can make some changes to the code or in the code. So you type for C in range of the length of example string 3. Print example string 3 C plus 1. And we can add some white space. And we have a string cast length of example string 3. So let's run this code. And as you can see, there are many ways to code similar solutions. So this is two different ways to reach the same result using different, you could say, methods. So all right, let's print the text backwards, or rather the same text structure backwards. So we type for E in range of the length of example string free, print example string free, plus white space plus string length example string free, and we close the print instruction. So let's run this code. And here you can see that we printed all the text backwards. And as you can see, Python has some very powerful functions to manipulate strings. So what we will do now is that we will take a brief look. Let's take a brief look at the element-based access in strings through the indexing method. So we start by printing example string free, and we print example string free, and we run this code, and here we have the string which we will access with the indexing method, and we will make selections from example string free using the indexing method. So we create an example string 5, which is equal to example string 3, 1 plus example string 3, and we can take a number 12 there, and example string 3 we can take, and here we will use example string 3 to print the word ear using example string 5 and some selections from example string 3. So here we can see that, for example, we select the first element of example string 3, and the first element is the second element in the array. So E is in position number 1, H is in position 0, L is in position 2, and the second L is in position 3. So 12, it refers to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have an A, and 8, which is an R, is this letter here. So let's run this code. And here you can see that Python strings are easy to handle and easy to use in Python. So right, this has been a fun short video lecture, and we have taught you a lot about Python strings and their fundamental nature, plus taught you to master the basics of handling Python strings. In the next video, we will teach you even more. and we look forward to see you in the next video. Hello and welcome to this video about Python string object methods. We are excited to have you here, and in this video you will learn to use some intermediate string object methods, or you could say functions, which are used to transform, change, manipulate or test the content inside a string object. These string methods can be used to search strings for defined content, to test the properties of strings, to change or update, and in the process create new string objects. And these string object methods are a great toolbox for data handling, both in terms of managing string data, but also in more general terms, as the string data object often is a transitional data form in various types of data handling. So, in this video we will teach you a collection of intermediate string object methods useful for the purpose of data handling with Python. We'll begin to talk about some string methods used to test the content of strings, tests which may be important when using strings in terms of data handling. And the methods we will learn to use are isAlpha, which tests if a string consists of only letters, and the isDecimal method, which tests if the string consists of only decimal characters. These functions are useful when converting data between string formats and numeric formats for computations, as they can test if the outcome of an operation, conversion, or casting of an object will yield useful results even before the computation occurs, with the possibility of having to catch errors. Similarly, these functions can find lots of data errors and other data anomalies, in particular when loading data files from various unknown or unstable formats. Two other useful tests we will look at are the isLower method, which tests if the characters in a string are lowercase, and we will also look at the isUpper method, which tests if the characters are uppercase. These tests return true if the test is true and false if the test is false. And these tests can be used to test strings for various types of comparisons, as upper letters generate different comparison values than lower letters for the same letter, or they can be used to check and control output and similar items. We will look at some methods for searching the contents of strings, such as the findEx and rfindEx methods, which returns the integer position of a finding of a string x inside a string, or a -1 if no finding is made. Another function is the countEx method, which counts the number of times a string x occurs in the tested string and returns an int describing the number of counted occurrences. These methods are useful to find strings or string parts if there is something to be found, the finding's location in the string, or the amount of times a string occurs in the searched string. We will also look at special methods for changing the contents of strings other than the assignment method, which you already know. So we will look at the capitalize method, which returns a string with the first letter capitalized and the rest lowercase. We will look at the lower method, which returns a string with all letters lowercase. And we will look at the upper method, which returns a string with all letters uppercase. And these methods are extremely useful to fix string text output, or for example in text mining to remove the amount of variation and make texts more equal for comparisons. And we will look at the replace x and y method, which returns a string which have all the occurrences of string x replaced by string y. And this is a method or function which is currently implemented in each and every word processor as the replace function. And this fact demonstrates its usefulness for any text operations. We will take a look at the split method, which is very useful for text analysis in that it makes it easy to split a sentence with multiple words into lists of strings where every string corresponds to a word. We will take a look at the strip, lstrip, and rstrip functions, which returns strings which have had the white space removed from them at the beginning of the string, at the end of the string, or both at the beginning and the end of the string. And these methods are useful to remove common whitespace additions to texts, which may confound analysis as whitespace, while invisible to our eyes is very real and has a numeric, or you could say string value, to the computer. All of these methods which we will teach you in this video are very useful for data handling. So, now we'll start our code editors and type some string code. So let's start up our code editors. All right, having started our code editors, we will start with describing our code. So we type some Python string object methods. And now we'll create some example strings. So we type create some example strings. Example string 1 equals hello. And we'll type that this string is intentionally misspelled in a strange fashion. We will create example string 2 world. And we'll type that string 2 uses uppercase letters. And we will have example string 3, which we will give a comma sign and the text again. And here we can type the comment that we only have lowercase letters in this string. And we have example string 4, which we set to 123.3. And this is a float as a string. And we have example string 5, which we set to an integer 32. An integer as a string. And we have example string 6, which we set to hello world again. And we type an ordinary string example. And we have example string 7, which we just make with a bit of white space. Hello. And a bit of trailing white space. So we call it hello with added white space before and after the visible string. And we have a example string 8, And this is the string or the visible string world with a comma sign and add the white space before and after the visible string. So let's run this code like this. And now we will make some tests on these strings. Let's begin with some tests on the strings. So we type print string 4 and we can use if alpha. Is it true or is it false? We can print if decimal, true or false. And we can print string 5 is numeric. And we can say that it is necessary to keep floats and integers separate. So let's run this code. And here we can see that string 4 is a float created as a string, and it is not alphanumeric, and therefore we get false. And we also tested if it is a decimal number, and because of the dot, it is not. We tested if it is numeric, and because of the dot, it is not. And we tested string 5, which is an integer, and it reported itself as true when we tested if it was numeric. And we can, for example, rerun this code without this dot. And now this is an integer. So let's rerun this code. First this code, and second this code. And here you can see that some of these tests on the string 4, which were false, turned true when the dot was removed. So, all right, we will conduct some more tests. So we will type print string 2 is upper. We will print string 1 is upper. And we will print string 3 is lower. So we will first test if string 2 has uppercase letters. And all these letters are uppercase, so it should report true. And we will test if string 1 has some uppercase characters, but here we can see that not all characters are uppercase, so it should report false. And we will test if example string 3 only has lowercase characters, and it has so it should report true. So let's run this code. And here we can see that string 2 is upper, is true. String 1 is upper, is false. And string 3 is lower, is true. So we can say that the tests are defined as native string methods and can be used to check the contents of strings before using, for example, cast methods on them. For example, to convert a string to an int or a float. And this is very useful when considering new loaded data files or to be used as a tool to make certain defined changes to a column or row or a list of strings in a collection. If the test yields true, you convert, otherwise you mark the item or object or row or column or part of a column or row for visual or automatic inspection of the issue. So you can use these methods to control the type of object you want to operate on, and you can use these methods on several string objects in a collection of your choice. And now we'll take a look at methods for searching for content inside strings. So let's type methods for searching for content inside strings. And the methods we will look at today: return integer positions, or you could say integer values, describing the positions of findings, and -1 or a -1 if no findings occur. So we type print string 6. And we print string 6 to have it closer on our screen. So we type print string 6 find world. And this method returns the position of the first item of the first element. And we will type print string 6 or find low. And this will return the last occurrence first element. And we will print find aircraft. And this will yield no occurrence and return -1 or -1. And this code will search our string 6, hello world again, for the strings given as arguments to the find or rfind methods. And the method will return the first finding of the string argument given the find method. For world, this will be position 6. For low, position 3. And for aircraft, -1, as the string is not present in string 6. So let's run this code. And the machine returns 6, 3, and -1, which are the starting positions of the string we are looking for. For example, world begins at position 6, which is 0, 1, 2, 3, 4, 5, and 6. And we have no aircraft in the string, and therefore we got -1 with the last piece of the code. So now we'll count the occurrences of a string using the string count methods. So let's type methods can count the occurrences of a string inside a string, and it is important to remember that while a string often is a word, a string can also be a sentence, paragraph, a book, or an entire library, or even more. And this makes the search functions incredibly powerful. So we print string 6, count. The number of else. In this string. So let's run this code. And this method returned 3. And here we can see that we have 1, 2, and 3 else. So now we know that the method counted the occurrences of the string L correctly according to the method. And this is an incredibly powerful function to find the exact number of occurrences of a string. And now we look at some methods that can change or replace the contents of a string, or rather create a new copy of the string under transformation. So we type some methods can change or replace the contents of a string or create a new copy of the transformed string. So we type print string 1, capitalize. We can print string 2, lower. String 3, upper. and string 6, replace else with once. So the first line will take the first example string 1 and it will capitalize the first character and make the rest of the characters lowercase. The second line of code will transform this uppercase string to a lowercase string. And the third line of code will convert or transform a copy of example string 3 into a uppercase string. And the fourth line of code will make all the else in our string 6 to be transformed into ones in a new string that will take string 6 place and name. So let's run this code. And here we can see that our first string, example string 1, was capitalized. Our second string was turned into a lowercase string, and our third example string was converted to an uppercase string. And example string 6 had all its else replaced with once. And now we'll take a look at a method that may split strings into lists of strings. So we will type a method that can split strings into a list of strings. So first we create an example string 10, which is equal to example string 7 plus example string 8. And this creates a new string. And we will print this new string. And we will create a list of strings. And this new list of strings will be equal to the new example string, which we will split. And this method splits a string 10 into subparts. And these subparts are coded to be the words of this example string 10. So we will print the list of strings, and we will make another printout. So we will, for string in list of strings, print string. So let's run this code. And here we can first see our new string, example string 10. And we can see that it has two words with a lot of white space around it. And we created this list of strings with the split method. And this created a list with two strings, hello and world. And here we can see that the split function removed the white space. And we also printed these strings as individual objects without the list. So we can see that the white space are removed from these two new strings. And now we'll take a look at the explicit methods for removing white space and explicitly modifying new string copies, for example, by removing, in this case, white spaces. So let's type methods can be used to modify new string copies. For example, by removing white space. So we type print string 10, and we only do this to display string 10 with white space. And we remark that e string 10 is equal to e string 7 plus e string 8. So now we will print e string 7 and use the left strip function on it. And we will add string 8 and use the R strip or right strip function on it. And we will print e string 7 and use the double-sided strip on it. And we will add some white space. And we will use the double-sided strip function on example string 8. And here we can comment that here we have a double-sided strip for both strings plus new white space. And you will discover why we add new white space, because these double-sided strips, they remove all white space. And therefore we must be careful to add this white space in this particular case, which we have constructed here. And we will also print example string 10 with the double-sided strip function. Here we will type double-sided white space removal for example string 10. So let's run this code. And here we can see that example string 10 has a lot of white space around the words. And we can see that the left strip and the right strip removes some white space but leaves the white space in the middle, plus that we cannot on the screen see the removed trailing white space regardless if it was removed or not. And that is something to keep in mind for some string operations, in particular when you will compare different strings with each others. Because a string that has white space and a visibly exactly equal string which not has white space trailing or in front of it will be different when you compare them, whereas they may look equal on your screen because you can't see the white space. So right, if we take a look at the 2 times double-sided strip of white space for both string parts, we can see that it looks good. But we remember that we had to add extra white space between the 2 words. So this is the result which we want to obtain. And if we look at the double-sided strip of white space In the last example, we can see that it works, but not for excessive internal white space inside the string. And in this case, you have two options. Either you do this operation or you split the string, which automatically will remove all the white space, and then you rebuild it in the same way. So you can rebuild it from this list of strings, but you still have to add this new white space. So we can say that controlled and careful splitting of strings tend to yield the most useful results, regardless if you're operating on a text document, social media data scraped from the web, or open-ended questions or other text data. And as the final part of this video, let's type. The applications and usefulness of string methods or functions are near limitless. And this is important to remember. For example, all you see in the news about artificial intelligence and all these applications are effectively about either managing graphics or sound or text and strings. And there are new applications and new usefulness, and you could say a stronger degree of usefulness of these string operations on a monthly basis currently. So, all right, this has been a fun video, and you have learned a lot about intermediate string object methods, or you could say functions. In the next video, we'll teach you even more. And we look forward to see you in the next video.